My name is Carly Scaron and I'm an 11th grader at Islands High School. My project is on anthropogenic noise and how it affects the reproductive success of songbirds, and this project was done in Savannah, Georgia, where songbirds are native. Anthropogenic noise is man-made noise such as noise you would hear on busy highways or neighborhoods. This noise has a detrimental effect on avian species. Birds rely on vocal communication for alerting for predators, mating and reproducing, and foraging. When anthropogenic noise is louder than the noise frequency birds use, it interferes with their ability to call to other birds, and they have to increase their energy expenditure. Having to use more energy throughout the day increases the stress levels in the songbirds, which can cause their health to be at risk. It's known that when stress hormones are secreted, reproductive hormones are suppressed. So the purpose of this study is to look at how noise affects the songbirds and their ability to reproduce. The study species we used was the eastern bluebird and Carolina chickadee because they're a native species. Our study site was Islands High School, where we have 3 retention ponds, a grassy area, and a forest that starts with a few trees on the edge and moves into a more dense deciduous forest. For this project, I had 3 habitat types. So the forest edge was the forest habitat type, and the grass habitat was the grassy areas around the athletic fields, and the water habitat was around the water retention ponds. We collected noise frequencies using a Decibel 10th app on an iPhone. We recorded for 45 seconds at each nest box and recorded the average and peak frequencies at each. With the data, we found that the forest had the least amount of eggs and the grass habitat had the most amount of eggs. We saw an inverse relationship between the number of eggs versus noise and the noise levels in each habitat. Where there was more noise, there were less eggs, and where there was less noise, there were more eggs. We ran one-way ANOVAs and saw that these graphs were statistically significant with p-values of 0.0015 and 0.002. Post-hoc Tukey tests were also run to look at how each habitat differed from each other. Post-hoc Tukey tests showed that the forest edge had significantly more noise in the grass habitat, and this was significant with a p-value of 0.0009. We ran a post-hoc Tukey test for the forest edge and saw that it had fewer eggs in the grass habitat, but the p-value was only nearly significant with 0.058. According to the data, noise does have an impact on how birds reproduce and if it is successful. Some studies have shown a decrease in species richness due to the harmful effects of anthropogenic noise, and this is because with increased levels of stress, birds have been known to flee their nests or even their offspring so that there isn't a risk of reducing fitness. Human conservation efforts have improved reproductive rates and fledgling prosperity of many avian species, so it would be helpful to explore the ideas of safety and seclusion from areas with high anthropogenic noise. To further this project, we could potentially discover how plasma concentrations of corticosterone relates to stress in this avian species according to the noise levels.